Hi everyone, welcome to my channel, Tutor Linear Test Prep. Today I'll be providing a full walkthrough of the Digital SAT Math Linear SAT Test Unique number 6. Quick disclaimer, this video will cover the linear non-adaptive SAT practice tests found on College Board's website. Many of the questions from these tests are duplicated in the Blue Book app, which I've already covered in previous videos. This video will only cover the unique questions, so there are no repeats. A link to the Linear Test Unique PDFs will be in the description. I highly recommend you complete the questions yourself before watching this video. Let's get started. Okay, this is Module 1, question number 2. I don't really have a whole lot to say about this one. When you make a line of best fit or a curve of best fit to some data, you're looking for two things. One, roughly 50% of the points on each side. And two, you want it to follow the path where the data is kind of trending. You can't do this on a digital exam, but you could like trace it with your finger. Kind of see like, oh, where is the data headed? And it looks like it's kind of going like that, which is answer choice D. So you see A and B are wrong, or sorry, A and C rather are wrong because they don't even have 50% of the data on either side. See, most of the data points are underneath the graph, so that kind of instantly rules those out. And then hopefully you can kind of see with C that even though it does have about 50% of the points on each side, they don't follow the path, the graph of the line doesn't follow the path where the data is kind of trending in any way, right? There's no, like if I were to say, oh, it predicts up here, you see that's not even close to the actual value at that X value, so. Anyway, so B is wrong as well, but just for a different reason. Great, let's move on. Okay, this is Module 1, question number 5. So really all of this question, there's a lot of stuff you should know about this picture, and I've gone over this in many of my previous videos, what the y-intercept means for a projectile, what the vertex means, and what the positive x-intercept means. But this question isn't really asking about any of that. It's just asking us about something else. It wants to know when is the height of the object increasing. So you don't really need to know any kind of formal definition. When a function is increasing, that means as you go left to right, it's going up. If it's decreasing, that means as you go from left to right, it's going down. Probably for this one, it's easiest to just guess and check. So I'm going to look at the first answer choice A, from x equals 0 to x equals 2. Trace it with my finger, and it certainly seems like it's going up during that entire interval. So A is correct. All of these other intervals have at least some part of it where it is decreasing, going down. Anyway, I digress. So if you look over here, that's where it is decreasing. So we would say it's increasing here and decreasing over here. It's going down to the right. You could still say, oh, it's increasing from, say, 1 to 2 or 0.5 to 1.5. It could still, the answer choice still could be like a subset of one of those intervals, but it has to be increasing the entire time. If you look at all these other answer choices, it's going to be decreasing at some time. It's going to be in the blue region at some point, which the question does not want. So the answer is A. We got kind of lucky that the first answer choice we guessed was right. Great, let's move on. Okay, this is Module 1, question number 6. I go over this in great detail, guys, in my Ottocento, I think it's the second one on unit conversions. Please go watch that. You really need to know unit conversions. They tend to be somewhat straightforward questions, so you really want to get them right. Even the hardest ones. It's not easy, but it's straightforward. All right, so we've got 1.116 inches, and we're going to set up a parenthesis factor label method. And we're going to put something from the unit conversion on the top and something on the bottom. I'm going to put the 36 inches on the bottom and the 1 yard on the top, so that you guys, as you guys can see, inches is on opposite sides of like the division bar fence, that means we can cancel them out. If they weren't on opposite sides, that means you did something wrong and you should switch the two guys in the unit conversion. So you see, each step of a unit conversion, you quite literally have a 50-50 chance of getting it right as long as you check. Most students, they don't check to see if it crosses out, so they get it wrong. Okay, now that I have this, even though this one's pretty straightforward, I'm going to go very, very carefully into my calculator and type it in exactly as it's written. So let's do that. So I'm going to do 1116. We're left with units of yards, which is what we want. And I get 31. So let's come back over here. So this would be 31 yards. So for the answer, we would say 31. Because this is a student-produced response. And that is correct. Great, let's move on. Okay, this is Module 1, question number 8. So for this one, this part here, remember guys, f of x is synonymous with y. So this is basically telling you when x equals 0, y equals 30. In other words, it's just telling you this point, 0, 30. Well, that equation up top should look pretty familiar. It's just a more specific variation of y equals mx plus b, where m is the slope and b is the y-coordinate of the y-intercept. Well, the question's asking us for b. See, it's the same. It's got a slope of 1. There's like an invisible little 1 here. And the y-intercept, we want the y-coordinate of the y-intercept. Well, when you have x equals 0 in a point, that point does tell you the y-coordinate of the y-intercept. So I go over this in all my videos. Whenever you see that x is 0, that means for a lines question, that y-coordinate is your b. So b is equal to 30. And that's it. No work required. They're just testing you on what the concept is, just what is a y-intercept. And when you see a point with x equals 0, the y-coordinate is the y-intercept, which is in mx plus b, b. Great, let's move on. Okay, this is Module 1, question number 9. It's just asking us to interpret a point using function notation. I went over this in the previous video as well. I've gone over this in many of my videos. Please, 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 guys, just write down what it means before you go to the answer choices. If you go straight to the answer choices, you're probably going to miss something. Okay, anyway, so the function they give us is p of t, and the point they give us is p of 0 equals 1800. So this is true for any function notation, guys. The letter inside here is this number, and then the letter over here is this number. So I'm going to translate it. When t equals 0, let's see what t is based on the question. T is the number of years since the study began. Okay, 0 years since study began, or in other words, when the study started. P is equal to 1800. What does it say P represents? The function P gives the estimated number of marine mammals in a certain area. Okay, P equals 1800 marine mammals in a certain area, blah, blah, blah. Okay, now that I have all that, I can go to the answer choices. The estimated number of marine mammals in the area was 1800 when the study began. Okay, that all sounds exactly like what we came up with, so I'm going to go with B. And let's see, that is correct. Okay. Let's kind of decompose why the other answer choices, let's break down why they're right, well, why they're wrong. So, the estimated number of marine mammals in the area was 102. There's no 102. How would we get a 102 from that point there? There's no 102 in here, so so that's wrong. Let's see. Increased by 102 each year. There's also no 102 in that point. So that's wrong. I'm guessing people are getting this from here, but that's not what the question's asking about. It's asking about this. That's saying 2% increase each year. That's what that's saying. You could do 100 times the percent multiplier minus 1, and you'd get positive 2% increase. So yeah, anyway, guys, don't look at the equation when they're asking you about a point. Just literally interpret the point. Okay, regardless, that's wrong. Okay, let's look at D. The estimated number of windmills in the area increased by 1,800 each year. Okay. That is wrong. That almost sounds like a slope, right? But the question is not asking us about a slope. First of all, it's not even a linear function, so there is no slope. And second of all, it's not asking us about a slope, it's asking us about a point, so that is wrong. So those are some of the keywords that would really jump out at me to tell me A, C, and D are wrong. A and C both have the number 102, and I have no idea where that's coming from. And D is not describing a point, it's describing a slope or a rate of change, which would maybe be the answer for a linear functions question or something, asking about slope, but it's not the case when it's asking about a point. Whenever they give you a point, guys, just go straight to interpreting this point. Just like I went over here, you can use this little color-coded legend to help you. Great, let's move on. Okay, this is Module 1, question number 19. So I go over this in my Ottocento on basic statistics. So please go watch that if you haven't already. I go over this in tremendous detail. This is finding the mean of a frequency table, or the median of a frequency table. I see that it says median number of employees. Okay, so the number of employees, because that's what it's asking for, that's the value. And then the other thing must be the frequency. So we will use the position of median formula. The position of the median is equal to n plus 1 over 2. I go over that in the video. They tell us that there's 17 restaurants, so n is 17. So let's write that down too. So the position of the median is equal to 17 plus 1 over 2. That's 18 over 2, which is 9. That tells us that the 9th data value is the median. Go over that in the video too. Please go watch it. Okay, so now we're going to just search for where the 9th data value is so that we can answer the question. So what I'm going to do is I'm going to cumulatively add these guys until I hit or exceed 9, and then I'm going to stop. So first I do 2. Okay, that's just 2. That's too small. 2 plus 4, that's 6. That's too small. 6 plus 2, that's 8. Still too small. Okay, 2 plus 4 plus 2 plus 7. That is 15. So we're going to stop there. And our median is going to be over here. Remember, guys, we have to go back to the value column to get the answer. The answer isn't 7. Okay, so we did that. We don't know what the median is, but we know it's between 20 and 25. Now we just use process elimination. This is too small. This is too small. This is too small. So the answer is D. Great. Again, guys, if you don't know how to use the position of median formula, please go watch my Ottocento video on basic statistics. This is really important, and it shows up on almost every exam. So great. Let's move on. Okay, this is Module 1, question number 22. I have a lot of videos on this, guys. I have Ottocento on percents, and I have a series of shorts on percents as well. In particular, this is percent multipliers, and there's a short on net percent change, which is essentially what this question is asking us. Well, more on that later. Okay, so I'm going to make a little table here. So we're going to start with 2007 and then 2008 and then 2009. I see these words 14% more and 4% more. I go over this in those videos I just outlined. Percent more is indicative of a percent increase. So we need to calculate percent multipliers for a percent increase using the expression 1 plus percent over 100. Before I even tackle the question, I always like to just calculate the percent multipliers and then write them down. That way I'm not doing two things at once. You guys kind of get what I'm saying? So let's pull this up. Again, don't do it in your head. They're going to give you tricky numbers, and if you do it in your head, you'll get it wrong. These ones aren't so bad. Just because these ones aren't so bad doesn't mean you should do it in your head all the time. Okay, just calculated both of them. Okay, so the percent multiplier for the first one is 1.14. Again, 1 plus percent over 100. That's for an increase, not for a decrease, just for an increase. And the other one is 1.04. Okay, so let me add that. Okay, let's come back over here. And let's say in 2007, we started with I don't even need this table. This isn't even important. Let me get rid of this. So original times percent multipliers equals final. Go over that in my Ottocento video and my shorts. And I'm going to say the original, how about we call that X? And then the percent multipliers are, they're consecutive in a row, right? So 1.14 and 1.04 equals the final. And we want to know why times as much in 2009. So how much more did they make times as much? So I guess I just need to go to the calculator. We don't even need to do the final calculation. So 1.14 times 1.04. And I get 1.1856. So y times as much. So 1.1856, I guess that's our answer. Man, really weird. Okay, D is right. Now, guys, this is still really important to understand. I'm going to write this on the board, even though it's in all the videos, so please just go watch those videos. These percents concepts are on every exam, like without fail, so you should really study all of them. It's straight up, most of it's just memorization, so it's a really good thing to study if you're first starting out. Okay, so the percent change is the net percent change. I go over this in my net percent change short, is 100. I mean, percent change always is 100 times the percent multiplier minus 1. Subtract 1, multiply by 100. Subtract 1, multiply by 100. So, let's go over here. We're going to do 100 like that. And you see, this would have been a follow-up question to make this question harder. They would have said, oh, what's the percent increase from 2007 to 2009? And they could have made that student-produced response as well, right? So the answer, if they did ask that, would be 18.56. You do 100 times the quantity percent multiplier minus 1. Great, let's keep going. Okay, this is Module 1, question 24. The very first thing I notice is that they're asking for tan of A. Well, angle A is complementary to angle B. Right triangle, right? 90 minus 30 is 60. So angle A is 60 degrees. You got to have 180 degrees in a triangle. So they want tan of A. So in other words, they want tan of 60 degrees. We don't really need the picture at all to do that. It's kind of a red herring. First, I highly encourage you guys get a scientific calculator that can do this. I go over this in my other videos. So we're going to actually do that first. Then we'll do the by hand method, which you'll see takes longer. Okay. Let me pull up the scientific calculator. Okay, so this is just, I'm just using, you can't actually pull up an app of a scientific calculator on your computer. Common misconception in the YouTube comments. Again, guys, it's like I have it in my hand. I'm just doing it on the screen for the sake of the demonstration. So if you want to buy a calculator that can do this, they often run for around $15 to $20. Anyway, so I'm going to make sure I'm in degree mode, which I am. And I'm going to do tan of, 60. And I get root 3. That's the answer. I would just lock that in and move on. Let's go back to the board. Okay, so we got tan of 60 is root 3, so that's the answer. C is correct. We'll go over how to do it by hand now. Once again, I don't really need that triangle. It's actually just going to make the numbers bigger and make it more work. So I'm going to pull the special right triangle from the reference sheet. Give me 1 second. Okay, so this is just my little recreation that I used in my Ottocento video on special right triangles of the 30, 60, 90, which is on the reference sheet. It looks exactly like that, just not purple. Okay, so we want to do tan of 60. I go over this in my Ottocento on SOHCAHTOA. You should absolutely watch that if you haven't already. So I'm going to circle the angle I care about, which is 60. And I'm going to label them using HOA. So the hypotenuse is across from the right angle. Okay, hypotenuse. The opposite is across from the angle of interest. And the adjacent is the third side. Now we're going to do SOHCAHTOA. So tangent tells us opposite over adjacent. So opposite over adjacent, which is x root 3 over x. You see the x's cancel out, and we are just left with root 3. That is it. Not that bad of a question, but it still would have took you most people, I think, at least 45 seconds to a minute to figure that out. Whereas you guys saw how fast I did it on the scientific calculator, like 10 seconds tops. So yeah, definitely think it's worth to bring a scientific calculator that can do trigonometry for you. It's just one less thing to worry about. Great, let's move on. Okay, this is module 1, question number 25. So I have a series of shorts on this. It's called Exponentials plus Time. There's 3 of them. You definitely go check those out. This is also on every exam. This is the most basic form, y equals a times b to the x, where a is the initial value and b is the multiplier. I mean, you could tell by looking at the answer choices, but still they tell you the initial value, when it was first featured, that's the initial value, is 40. And the multiplier, it says increased by 190% previous hour. Okay, that word previous tells me it's actually getting multiplied when x goes up by 1, so that tells me it's exponential. If it said of the original amount, that would be linear. It sounds like it's exponential, but it would actually be linear. Anyway, this one's exponential, so that word previous is a good sign here. And it says increased by 190%. So just like we did a couple problems ago, we have to do a percent multiplier for an increase, which is 1 plus percent over 100. Many students would just do this in their head and get it wrong. So I'm telling you guys, don't do this in your head. There's no reason to. Absolutely no reason to do it in your head. Okay, 1 plus 190 over 100. Okay, I see that's 2.9. So it's got to be answer choice D. All right, let me go back here. So many people, guys, so many people would do it in their head like a percent of, and they would put 1.9 and they would forget to add the 1. Almost everyone, many people would pick answer choice B, but you guys see that just isn't right. So please make sure you know how to calculate a percent multiplier and calculate percent change. It is literally just typing stuff into the calculator. You should be able to do that. You're capable of that. Okay, let's move on. Okay, this is module 1, question number 27. So I'm first going to draw this picture. I don't know, it's going to be easier for me to do it over here when I do it off to the right. It says C is a right angle, so why don't I call this A, B, and C. Then it says point D on side AB. Okay, so I'm going to put that here. Point D is connected to a line segment with point E on side AC. Okay. Such that line segment DE is parallel to BC. Okay, so we have this, and this guy is parallel to this guy, which means that it's a right angle. This is a shape that, hopefully you can kind of see it's a right angle. This is a shape, nested right triangles. It often tests on similarity. This is on the SAT all the time, so I've seen this shape many times. So it was easier for me to come up with it. Great. Okay, so now it says side BC and CE is equal to 2 times AE. What is the length of line segment DE? Oh, they also tell us BC. I missed that. BC is 162. Let's put that. And we want to find the length of line segment DE, which is X. Okay, and CE equals 2 AE. So what I'm going to do is I'm going to label this one AE as Y. And then I'll use a different color. How about green? We'll call this guy Y. And then we'll call CE 2Y. But really important, guys, this is not the side of a triangle, so we can't use this in similarity. So Y plus 2Y is 3Y. Now I think I can do, I mean, you can kind of see it differs by a factor of 3. But I'll still go and set up the proportion. So big over small equals, okay, how about 3y over y, which is just 3 over 1, and 162 over x, corresponding big over corresponding small. These triangles are similar, so we can do that. Let's see, now I'm going to cross multiply, so I get 3x equals 162. And let's see, what's 162 divided by 3? I get x equals 54, which is the answer. Okay, so a couple important tidbits for you guys, a couple subtleties that might have tripped us up. So for starters, you see this segment here and this segment here. They're not sides of a triangle, so you can't use those in your proportion. So notice how I had to figure out the big side. I had to add them up. So that's something a lot of people would have missed. So I'll actually just leave that highlighted. Don't use those two sides by themselves in a proportion. It's never going to work. Okay, because they're not sides of a triangle. They're sides of a trapezoid. Okay, and the other thing is, Kyle, I know you've done many problems, but how did you know it was similar? Well, they told us those two sides are parallel. So when parallel lines are cut by a transversal, we know that the corresponding angles are equal. So this angle is equal to this angle, and this angle is equal to this angle. So they're similar by the angle-angle similarity criterion. Again, I don't want to just say like, hey guys, if it looks similar, it is similar, or hey guys, if they tell you it's 2 times, it's probably a similarity question, but both those things are true. These kind of clues probably tell you it is a similarity question. But if you want to be really particular, they're similar by angle-angle similarity, and I'm sure there's some other theorem that's very specific to a right triangle and a right triangle, but I don't know the name off the top of my head. Again, the SAT doesn't expect you to know it. Great, let's move on. Okay, this is Module 2, question number 9. Whenever you see ratios, guys, I go over this in my videos all the time. A to B, A colon B, and A over B are all equivalent. Almost always on the SAT, we're most comfortable with fractions, right, guys? So almost always on the SAT, you can get away with just making a fraction. So that's what we're going to do. So it says the ratio of xy to, okay, so divided by zv is equal to, notice how I'm going in the same order, xy to zv, and then is 6 to 1. So I'm going to do 6 to 1. And then they tell us xy is 102. So pay very close attention. That goes on the top. You see, you got to put this stuff in the right place. If they mixed it up and, you know, the xy goes on the bottom, you might not realize it. So just pay close attention to that. Okay, so the 102 goes on top. And then the length of line segment ZV, I don't know, why don't I just call that Z? And we get this nice proportion, and now we're just going to cross multiply and divide. So I get 6z equals 102. I'm going to divide both sides by 6. And I get 17. And that is answer choice A. And that is correct. Great, let's move on. Okay, this is module 2, question number 14. Let's see, it says a rectangle has an area of 155. The length of the rectangle is 4 inches less than 7 times the width of the rectangle. What is the width of the rectangle in inches? Okay, so area of a rectangle, which is equal to length times width, they tell us is 155. And they also tell us, this is really important, the length is, okay, so L equals 4 inches less than 7 times the width. Less than is like a turnaround word when you do a difference. So you have to do not 4 minus 7w, you have to do 7w minus 4. So that is really important. These keywords tell you to kind of turn around the difference, make sure you understand that. It's just English being English, right? Like 5 minus 2 is 3, but we would say 3 less than 5 is 2. We say it backwards for some reason. Sometimes. So just be on the lookout for that. Okay, so now that we got that, this just becomes a system of equations. So we have, I don't really need this anymore. We have LW equals 155. And I'm going to substitute in for L. And I get 7w minus 4 times w equals 155. I'm going to distribute, and I get 7w squared minus 4w equals 155. And I'm going to subtract 155 from both sides. At this point, guys, I really would just type it in the calculator. I really don't want to do this. Let me see if there even is a good way to factor this. Okay, this is complete garbage. So if you did the AC method on that number, 7 times negative 155, would be so big, and it would be so hard to come up with factors. So I'll write them, but again, we're going to do it on Desmos anyway. I wouldn't do it this way on the actual thing regardless. So it factors out to, I go over this in my factoring, Ottocento factoring video if you want to learn the method, which is important, but not for this question. This is just not worth it. These numbers are too big. So it factors to 7w plus 31 times w minus 5. And if you set each of those equal to 0, using the zero product property, we would add 5 to both sides and you get 5. And then for the other one, you would get subtract 31, 7w equals negative 31. And then you would get w equals negative 31 over 7. But that's impossible because you can't have a negative width. So we would cross that out. The answer is 5. Okay, so you could type in the equation we came up with, 7x squared. 7x squared minus 4x minus 155 equals 0, and you'd very quickly see the answer is 5. You can't have a negative width, so it would be 5. You also can just type it in straight from the beginning as a system, so I'm going to show you that now. So let's say I made length x, alphabetical order, I make length x and then wy. So I'm going to do xy equals 155. That's the area equation we came up with. And then the length equation we came up with is x equals 7y minus 4. And we want to be in the first quadrant so that they're both positive. And you can very quickly see that the length is 31 and the width is 5. So if you knew how to come up with those two equations and then swap out the letters with x and y, you could have been done with this in probably under 30 seconds. That's probably what I actually would have done. I definitely wouldn't have done AC method with like a 1100 or some giant number that would take so long to come up with manually. Okay, great. Let's keep going. Okay, this is module 2, question number 15. Again, guys, I go over this in my Ottocento on basic statistics. I also have a series of shorts coming out on most of the topics from that video as well. Should be out pretty soon. Anyway, so I go over here. So we're going to first put the numbers in order. You always got to put them in order for a median. So let's see, 4, 4, 4, 5, 5, 6, 10, 18. I think I did that right. Okay, how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8. There's 8. So I'm going to do position of median equals n plus 1 over 2. So 8 plus 1 over 2. That's 4.5. So I'm going to take the fourth number and then one bigger than the fourth number, the fifth one. So that is these two. And I'm going to average them. See, 1, 2, 3, fourth, and then fifth. And then average them. The average of two identical numbers is just that number. So the median is 5. Again, if that was too fast, please go watch the Ottocento Basic Statistics video. I go over it much slower there. And that is answer choice B. And that is correct. It goes without saying that you could do this very easily, median of a list very easily on Desmos. So let's do that now. So you could either type in a list using square brackets. I'll just do that. You don't need to put them in order. 4, 10, 18, 4, 4, 5, 6, 5. And then you could do median of A. You could also just type it all in one go, but I think this makes it a little bit easier to look at. Also, what if you had to find the mean as well? Then you could type in mean of A. So it tells me 5. Great, let's keep going. Okay, this is module 2, question number 16. So the thing they expect you to know about cylinders and prisms is that the volume is equal to the area of the base times the height. That is really important. You see, if you look on the reference sheet and look at the formula for a cylinder, pi r squared height, you'll see that, oh, pi r squared is the area of the circle. So it is just another way of writing this. Anyway, so I'm going to swap that out with area of the base. You see it's the same thing. Okay, they tell us that the volume is 432, the area of the base is 24, and we want to find the height. Well, we're going to just divide both sides by 24. And we get a height of 18. There's nothing funny going on with the units. They all have the same type of unit. It's all in terms of centimeters. So the height is 18. That is answer choice A. Let's see. That is correct. Great, let's move on. Okay, this is module 2, question number 18. So the concept they're testing us on here is that perpendicular lines, they cross at right angles. But the thing that they really want you to know is that the slopes of perpendicular lines are opposite reciprocals. Opposite means change the sign. Reciprocal means flip it or raise it to the -1 power. So change the sign and flip it. So, for example, if the slope were 2/3, the perpendicular slope would be -3/2. Anyway, so this one, if we do mx plus b, we see that the slope of the first line is 7. So 7 is the same as 7 over 1. So the perpendicular slope, we flip it 1/7, but then I have to change the sign. So it's positive, so I have to make it negative. So the answer is B, and that is correct. I suppose if you weren't sure, you also could guess and check using Desmos, so I'll do that now. So just kind of by eyeballing it. So y equals 7x plus 1/8. And the y-intercept doesn't really matter, so you can just come up with any random number. I'll do mx, I don't know, how about plus 2 or something? And the perpendicular slope, I'm going to do -8. That's not perpendicular. That doesn't look like a cross, right? Doesn't look like a T. Okay, let's do 1/8. It's closer, but that also doesn't look perpendicular. Let's do 7. That's parallel. That's not perpendicular. They're going the same way. If I zoom in, you'll be able to see it better. Okay, let's try -1/7. Doesn't that look like it's making a perfect cross? And again, if you change the y-intercept, it doesn't matter, you know. You can do whatever you want for the y-intercept, but just kind of visually inspect it, make sure it crosses at 90 degrees before you move on. Great, let's keep going. Okay, this is module 2, question number 20. So, there's a couple things this is testing us on. I mean, first and foremost, this is testing you on your understanding of exponents and radicals. So I'll put a big box around this. The bth root of x to the a is x to the a over b. So you see the power goes on top, root goes on the bottom. Just like a tree. Trees have roots, they go on the bottom. Okay. So for example, the 11th root of x to the 4th would be x to the 4 over 11. Square root of x, when you don't have an exponent, the implied exponent is 1. And when you don't have a root, the implied root is 2. So this would be x to the 1/2. I mean, that shows up so often, you just want to remember that. Let me write that a little nicer. Anyway, so hopefully you're kind of getting the idea. We want to write it like that so that we can compare it to the left-hand side using what's called the 1-to-1 property. That's not important. So 4 to the 8c equals 4 to the power on top, root on the bottom, 7 over 3. Now you see, oh, we have the same base. So the 1-to-1 property tells us that if you have a to the b equals a to the c, then b must equal c, right? If they're both 4 to something, we don't have to do anything with logarithms. They just want you to recognize that these two guys have to be equal because the bases are the same. So 8c equals 7/3. Now I divide both sides by 8, and I can just do that on a calculator. 7/3 divided by 8. And I get c equals 7 over 24, which would fit in the grid, and that's the answer I would go with. That would fit in the student-produced response. Okay, what's great about this one is we can also do it entirely on Desmos. So let's do that. All right, so first and foremost, I'm going to change the c to an x. So keep that in mind. To do a cube root, you can either go in the functions menu, which I'm not going to do, but just so that you know that's there, I never use that. The shortcut for a cube root is CBRT. So CBRT, 4 to the 7. And you'll notice that, okay, I can't click on that, so that's a problem. So when that happens, remember we talked about Desmos lesson number 1. We break it into a system. So I'm going to start over. Y equals 4 to the 8x. Y equals CBRT, 4 to the 7. I zoom in, and I get 0.292 for x. And let me show you the actual answer. 0.291666666. Okay, so if you put 0.292, that would have been wrong. I go over this in my Desmos lesson number 18 on student-produced response. If you put 0.292, that would be wrong because it's not truncated to 5 characters. But if you put 0.292, that would actually be right. So you could have just, because this question didn't have a follow-up question, you could have just typed it in and then wrote the decimal down as your answer. Just remember, if there's if that 0 is optional, you want to include that optional 0 because it counts as more characters. Again, it's the stupidest thing in the world. I don't know why that's a thing. But if you include that 0, Desmos will give you enough precision to get it correct in exact situations like this. So I hope that's helpful to you. So 7/24, or if you didn't know how to do it, just type it in and put 0.292. Again, don't forget that 0. Great, let's move on. Okay, this is Module 2, question number 27. Please, 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 guys, go watch my Ottocento number 6 on how many solutions. It's the best video I've ever made, doesn't have a lot of views, and it goes over everything on this perfectly. So please, please go watch that. There's a worksheet. You can learn exactly what to do. It seems scary, but this is a very routine question that they ask all the time. Okay, so from this video, I'm just going to follow the strategy exactly. This is called messy standard form. What I'm going to do is, first I'm going to see if there's any fractions and clear the denominators. I see that the second equation has a fraction with a denominator of 8. There's no other fractions, so the LCD is 8. So to get rid of the denominators, I'm going to multiply the whole equation by the LCD, which is 8. The first equation I will leave completely unchanged. Okay, so the second equation is going to become 8ry equals 1 minus, what's 12 times 8? 96. Minus 96x. Now we want to get all these equations in this kind of nice ax plus by equals c form. It doesn't have to be standard form, but it should look like that so that we can set up proportions. So the first one I'm noticing, oh, the x, this is nice. I like that. I like that. I like that. But I don't like where this guy is, so I'm going to move him to the other side. To do that, we're going to subtract 48y from both sides. So we get 48x, what's 64, negative 64 minus 48? Negative 112y equals 24. So all I did was subtract 48y from both sides. Again, I moved this guy over here. Okay, he looks good now. Now I'm kind of happy with this guy where he is. I'm happy with this guy where he is, but I want to move this guy to the other side. To do that, we're just going to add 96x to both sides. So we get 96x plus 8ry equals 1. And now I am ready to use the equation that we went over in the Ottocento video. This question says we have no solution. So the equation we talked about for no solution, where is that right here, is a over d equals b over e, which is not equal to c over f. That's just something you got to know. Okay, let's come over here. Let me highlight all these constants, make it easier for you guys to see. Negative 112, 8r, and 24 over 1. Okay, so let's write that all down. 48 over 96 equals negative 112 over 8r, which is not equal to 24 over 1. Okay, so I don't really care what it's not equal to because that's not going to tell me the answer. So I'm going to cross this out, don't care. And I'm going to come over here and circle this guy. And now I'm just going to cross multiply and divide. 48 times 8 is 384r. 96 times negative 112 is negative 10,752. Negative 10,752. And now I'm going to divide both sides by 384 to get r by itself. And I get r is equal to negative 28. And that is the answer. Great. Okay, so you see, guys, there's a reason why I spent so much time in that video going over these strategies is because even though these problems are long, I'm yet to see a question where that strategy doesn't work. So it's really helpful to learn these strategies and know these equations for the proportions. You can imagine if we got these, if we did substitution, or if we got the slope-intercept form, there'd be fractions maybe, and this problem would get really messy really quick. Getting rid of the fractions and then putting it in standard form helps you solve it in about 3 or 4 steps of work. Okay, so before I move on, what I like to do is I like to type in the original equation and make sure I did it right. So let's do that. Ry equals 1/8 minus 12x. Okay, and so I just typed in everything verbatim from the beginning of the question. None of my work. And we said r was -28. And let's see, if I zoom in, it certainly seems like these are parallel lines. So it seems like we did a good job. You also could, guys, right? If you wanted to. This is tough if it's student produced response, especially if the answer is a fraction. But if you really had no idea, you could try to use the slider. Be like, is that giving me parallel? No. Like, oh, it's probably somewhere over there. And you can maybe guess and check, but if the answer is a messy fraction, that's not going to work. I would highly suggest you learn how to do these questions by hand. Great, let's keep going. Okay, that completes the lesson. Please like and subscribe for more digital SAT math content. If you're interested in my tutoring services, the link to my website will be in the description. I tutor SAT math and all math subjects from about 7th grade to AP/early college level. Thanks for stopping by, and good luck studying.